Alright, I'm about ready to bond up. I have prepped the surfaces. I'm going to bond this up in I'm going to do the bottom first in the bottom half of the mold. Rick has made us some fixturing off of the mold itself to align the ribs and the spar. And I'm going to use those, and I'm going to bond up into the first skin. This full bond up is just going to be a static test article and to test the entire system before I go and commit to a bunch of them. These are the skins that had the bag failure or the low vacuum bag. They're cosmetically unacceptable, but they're probably just fine structurally, but we're not going to fly them. We're going to go break them. So let's bond them together. All right, she's all bonded up into the lower skin. Everything is square and justified against the OML lines, which are tooled into the vertical pieces of the mold. And we'll let it kick off and pop it out and evaluate it for the fit of the top skin. And we'll do that tomorrow. Katie has arrived. He took out another half a ton of trash and then flew. How much did you fly last week?
53 hours.
Oh, jeez.
It was a busy week last week. and two check rides.
Okay, what we're doing today is that we're gonna try and close this out. This is our test article, and we're gonna try and get complete load path in and out and see how much weight we need to put in the nose joggle to get it to balance. Now I calculated out we should basically just be able to do it with a 3/8 inch steel tube. That might actually be a little much. Right now it is, the CG is about right here. We need it to be about right here, which is 0.7 inches above this datum line. This is a horizontal datum line. It needs to be parallel to that, about out to here. So this is about CG right here, and we need to be, we're here, we need to be here. So Katie's going to take care of this morning, work out how much ballast we need, and then we're going to try and close this thing out. My job is to get this bracket and those holes in their correct location. So that we can get a complete load path, and then we're gonna test this, and Katie's probably gonna break it. All right. We have weighed and found to be wanting. We've weighed, we have measured, and we're a couple ounces over. I'm proud of us because we're counting ounces now. We're trying to get down to our weight. So we're at just a smidge over. So we're going to have to sharpen the pencil just a little bit more. We're going to make things just a little bit lighter, and then we're at the this is what it weighs part. The issue is the nose weight. We're at what are we at, 14 ounces or a little bit over. No, we're a little bit over a pound.
17.3.
No, we need that's too much nose weight. We have to take some weight off of the tail of this assembly to get back down on our total weight. Once we're balanced, here, let's try and pull this up for balance. There we go. Yeah. So once we were balanced with both skins on, we're carrying just over a pound of nose weight, which in the annals of airplanes is a minor miracle, but we need to be tighter than that. So I'm going to dig in. We're going to close this thing up and we're going to test it, and we're gonna test it for its max bending moment and for some torsion, and then strap it to the top of the car and take it through Mach 1. These are almost ready to pull again. I had to do some major surgery on this because I think I made a mistake. I had to reprofile this one, which is what all of this monkey motion is about. I had to reprofile it, put a strong back in it, and get it back conforming, because I think I just over-sanded it about a year and a half ago out of despair. This one's good. It had leaks. I found out where they were. It's between this shitty-ass gel coat I used, and it's down in the corners. Of course, it was never designed to have all of these sharp corners, but you know, fuck it. I ground all those out. I think it's going to be, it'll pull a full vacuum this time. But these are not terribly difficult parts to make, but it took me 4 hours to bag them, and they were never quite right. So that's why they are now test articles. All right, that's where we are. Dad's going to come by in an hour or so, and we're going to go to lunch. Make your peace with God. All right, we're about to pour a mixture of
Iron
oxide and resin into that corner. And this is going to get ugly. I mean, literally ugly. Now, Katie's weighed this out. We know approximately how much we need. And we're experimenting here. We're seeing if we can get this material to do what we want in the location that we need it with the least weight. Now, we'd have used lead if we had it, but this is what we have, and it's pretty good density. The objective here is just to get it as far forward as you can possibly get it. All right, we're probably going to get away with that. We'll babysit that a little bit. Maybe we put some peel ply on top of that and just shape it a little bit. Let's try that. That way we can get it a little bit better. We'll just keep babysitting this, but this looks like it's going to keep us on weight and with the minimum amount of extra. You know, we're proud of ourselves. We're chasing ounces now, but this is painful. This is painful. Okay, that turned out really nice. So Katie worked it to where this is the best it's ever going to get. That is as far forward with the best moment arm that we can possibly get. It's the correct amount of material, and we just hope it doesn't catch fire. All right, we're about to...
Easy for you to say.
Yeah, I know. We're about to the read it and weep part. We are about to bond this up. We're going to put it into the lower skin, upper skin, whatever, the non-joggled skin. Everything's been prepped. We have the cured out counterweight. We're not terribly happy with the weight of all this. We're coming in just about 7 pounds with the counterweight, but I can maybe save 6 to 8 ounces on this thing, but we are to the read it and weep part. This is just what this thing weighs in this material. I have drilled the holes. My quick and dirty drill fixture works in principle, but it's not going to be. It needs to be made correctly. Right now, it's just too fragile. And we're gonna pull it apart. Goop it up. Try not to add too much weight in goop. One of the problems with this is that there's a lot of goop under the spar simply because I made a decision not to completely follow OML with the spar, and I think that costs about 6 ounces. And since we're counting ounces, that kind of sucks right now, but we're gonna have to eat that one. Anyway, we're gonna pull this apart and load it with flocks. All right, Katie's mixing up mass quantities. By mass quantities, 8 ounces, 6 and 2, 8 ounces of resin. We're gonna mix up some flocks, and we're gonna hit it. So these have been prepped. These have been prepped 60 grit, and they have been cleaned with isopropyl alcohol, and we shall never touch them with oily hands again. So the strategy here is that we are going to load up the flocks onto these surfaces. We'll flip it over onto these surfaces, and then we're going to strap it down with this stuff. Okay. We are just about ready. We've got flocks everywhere. We have good prep. We have a 60 grit prep. We're cleaned with alcohol. And we'll just do a little touch up, and then we're gonna slap this thing together. I know for a fact this kind of stuff. This is just welcome to process development. Katie and I resorted to some redneckery. Okay, there's some trucker's hitches in here. There's some strappage. There's some tapage. But we got what we think is a good bond. That's probably not what I'd use. That's not going to hold up. Just use the.
I was thinking that wouldn't bond as
Here,
easily.
try that. At this point, we don't care. We got a lot of cleanup to do. But we got nice squeeze out. We're pushed down into the OML, such as it is. We use 12 ounces of stuff. Hopefully we don't really actually have 12 ounces in there. I think we're probably 10 ounces, which still pisses us both off, but it is what it is. So we are to the read it and weep part of the program. And we will weigh this son of a bitch, and then we'll try and break it. This is the first test article. of the horizontal stabilizer, and it came in a little porky for us, 7 pounds 6 ounces.
What are you looking for?
I wanted my calculated was 6 pounds 4. I'd like to see under 6 pounds if I can get it. Okay. This is a perfectly flyable article. It is within a lick of fill and paint of being perfect, but I'm just not happy with the weight yet. And if there's a couple of things I can do with it, we're going to test it. We're going to build a test rig, and take it to its design load. Design load's 500 pounds. Okay, that represents 10 G's and 500 miles an hour.
How are you going to do that? You're going to stack 500 pounds? You're going to hold 500 pounds on the end? You're going to hold it up out there?
Well, we got a load cell. We have a load cell. So I built a drill fixture, and we're gonna have to make this bracket, which I went into this a little earlier, but
Oh, okay.
this,
Right.
yeah, I went into this.
Look, if it's in the other one, don't worry about it.
Yeah, so the pin goes through here. This is the hinge pin,
Right.
and it goes through here. And so we're gonna load all that up. We're gonna tap these holes, 1/4 28, and then this is a 3/8 shoulder bolt. The real hardware is not. I don't have it yet. I have to have it made, but this is perfectly acceptable for a test. This is a bushing. All right, so we'll bond that bushing in, and then we'll make a test fixture, and we'll use the crane, the engine crane, and we'll make a test fixture. Are you okay, Dad?
Don't worry about it.
Sorry. Everything in the shop bites you. there's everything in the shop will bite you. So we'll put it on the test on the crane. We'll put the load cell on, and we need to have.
You're worried about the load on the axis more than anything.
I'm worried about load everywhere. I'm worried about it taking the bending moment. Okay, and it's the bending moment at 500 pounds at center mass.
Okay, yeah.
Or at
You
aerodynamic
don't want
center.
distortion or anything at that point.
Yeah,
Yeah.
by the numbers, it ought to be there ought to be a deflection on this spar of a fraction of an inch. I have to go back and look. I think I can take out more spar. I think one of my problems was right here in this. The fit of the rear of the spar, which is roughly this area, is not very good. It's because I straightened the edges of the spar, as opposed to make them follow the OML. All right, I drew a straight line from here to here. The front is precise, but there's so much fill back here. I think there's 8 ounces here. I think I've got a pound of flux in here, and that's unacceptable to me. I have a large area bond under the spar. Now, I made the spar as one unit because I don't like to have I could have put that unidirectional material into the skin, but that would mean I'd have a secondary bond in a primary structural component, and I don't like that. I like to have everything co-cured in. So I want the spar caps and the shear webs all as one finished unit, and then they just bond in. So that's why I did it this way. But I think I can remove this much material from the rear and save about 8 ounces, maybe even more than that per skin, right? And then this rib, a little porky. I think I can bring this down a couple of plies, and I can bring this rib down a couple of plies. This rib's going to stay the same as it is. This carries and transfers all the structural loads. It carries and transfers the structural loads from the counterweight, which is in here. We poured the counterweight. Let me show you that. Just stay there, Dad. So Katie came in yesterday, and he put together a test. We were using iron oxide and epoxy to do this counterweight, right? And he just set up a test to get the optimum ratio of resin to iron oxide to get the best density that we can
So
get.
that's what you're
And
making your counterweights out of, mixing those two.
yeah, resin and iron oxide, and it works beautifully. It conforms to everything.
He's a handy guy.
Handy guy. So it's a matter of getting as much iron oxide into it as you can and still have it hold together.
Those are different weights, I presume.
These are different. These are different ratios
Okay. Ratios of, yeah.
of iron oxide to resin by weight.
Okay.
Okay, so that one's 10-1. I can not quite read that one. 8-1. The 8-1 seems pretty optimum. Okay, the 10-1 is actually about the same weight, but we're looking at handling qualities. Okay, it starts to get very, powdery. This is like cooking. This is really what this is. This is like a big baking shop, right? So it's like how much water do you put in your flour? That's really what this is about. But that 8-1 seems to be right, and you can pack it in there. The idea is to get it as dense as we can, so that we can get its moment arm maximize its moment arm, minimize its weight, maximize its ability to counterweight the whole system. So this is a fully counterweighted full flying surface. It is 100% mass balanced around the axis of rotation. That's absolutely necessary. So that accounts for almost a pound, right? If I can take weight off the rear, I can take weight off the counterweight, and that's the strategy. If I can take 8 ounces, or if I can get 10 ounces out of here, I can get roughly 10 ounces out of the counterweight, and I can get back down to where I want to be weight-wise.
Yeah, that's more than a pound.
Pardon?
That's more than a pound, right?
Half a pound.
Half a pound.
Yep, 16 ounces.
16, oh, yeah.
Right, 16 ounces to a pound. So
If you're taking 8 and 8.
right.
So, yeah.
I'm a pound overweight.
Okay.
That's not a lot. Okay, that's not a lot, but it's a lot. Okay, in terms of percentage, it's just unacceptable to me.
Yeah.
Right. So we're gonna keep going. We're gonna see if we can find that pound.
Did you, when you designed that, do you have a margin of error between one and one, or did you write up for each one of these things? Do you have a acceptable tolerance?
For weight?
You weight on these items that like, is that acceptable weight, overweight, or if it's a pound?
Well, my concern is if I'm what is that? I'm a pound over. That's not 20%. It's like 15% overweight. If I do that everywhere, and if I give up that pound, and when I know I can get it, then the chances of will the airplane fly and be safe? Sure, but I'm giving up performance.
Right?
I'm giving up performance. I'm giving up range. I'm giving up payload. I'm giving up everything.
You'll have to fly skinnier people.
So the bottom, that's right. Everybody needs to go on diet, all right? Okay. I'm not naming names. Everybody's on this whole shop is in training. Is what's going on. So, but yeah, it's all about weight, and it's all about weight and power. So I'm trying to maximize this. If I don't go through this process here, and I don't fight for this pound, I can't get into that habit, because you do that, then you're not, then you got a pig, right? So anyway, but we're going to evaluate this. I'm not going to make another one of these. I'm going to set this aside until we test.
Battery's getting low.
All right. That's about enough.
We're on.
All right. So this fixture's coming along. Here, I'll just pull this one down. So this is the main bulkhead, transfers all the loads of the fan into this casing. And these are here as alignment tools to keep these sacrosanct, keep this and this parallel, keep these concentric, keep the concentricity of these items and the parallelism of everything in place while we bond up. And I just covered it with some epoxy and let it kick, and then, you know, sanded it out 400 grit. And we'll wax the crap out of it. And
Are these a permanent part of it?
nope, this is just the fixture.
This is just a fixture. Okay.
Yep, this is just to
Just
control all
in
the
place where you get it all set
control
up.
all the alignments.
Yeah.
Okay. I bought a grit blaster, which you got to put together.
Cool.
Because all of this this is relatively easy to prep, but the backside of this is not terribly easy to prep. Best way to do this is with a grit blaster. I will sand it roughly smooth.
The dirt blaster, you mean, is that like a sand blaster?
It's a sand blaster, 70 grit. It's just the best way to prep for composites, for bonding of composites. So I'm going to sand this roughly flat. There's some artifacts from the bag. Okay, this is the back of the bag. This is what it looks like when it comes out. So you got an A side and a B side to the bag. There's the tooled side and the untooled side. Because of how I designed all this, this is the untooled side and it needs to be body worked. So I'll sand it down. I will de-shine it with a grit blaster. I bought one that's big enough to have. It was on sale. That way I can get Harbor Freight, $200. Okay.
Really?
Yep, $200.
I love those people.
Yep, couldn't go wrong. So I'll set this up, throw these in there, and then I'll probably do one pass of micro balloons and epoxy, sand that back, and then we'll start the body work on this. Inside, I'm just going to leave the way it is. It's got a nice tooled surface. These have to be scuffed for bonding because they bond together. So those go together. And then so there's a large area bond, but it's a good net fit, so that there won't be that much fill there. I am modifying this tool. I've taken this out a little bit so that I can close up this gap. So this gap right here, come right here, Dad.
Over here.
Yeah. That gap is created by this part of the tool. Right. So when I laid this out, I had accounted for extra material here, but I kind of overdid it. So I'm just taking that back so that I can straighten this line up a little bit and tighten this gap up. That's all. That
makes sense, really.
Yeah.
Yeah.
And then we're modifying. This will stand. Yeah. And we're modifying this a little bit. I've got to pull this in because it was about almost an eighth off here. So I have to bring this in so that these two sides come up straight parallel. There's no fill here. When these are together, there's a little bit of fill, and I'm going to correct that before we make it again. Okay, you can see it up there now.
Yeah.
Right. I'm going to correct this. I'm going to tighten this up, and then we're going to pull 4 more of these. All right. Well, we needed a grit blaster, and Dad's going to put it together. He just got the welder up, got a plug on that, so
Just a few pieces to put together.
Yep.
And
Yeah.
we'll be doing it. We'll get her
Yep.
done.
Okay.
All right.
This looks pretty good. I'm about to crack this out by taking off all of these flanges. And then we'll see what we have. All right, it all looks very nice. Near perfect cosmetics, not quite perfect, but we'll take a B+ around here. last of the flanges to come off is this front one. Let's see if I can do it one-handed. Yep, there we go. And there's just some artifacts from the, looks like I didn't clean that quite well enough. Well, it's all good. It's all very flat. It's got excellent resin content. Hard as hell. Now we'll just pop it out. We'll see what we have on the other side. Okay. And it took a little bit of the finish putty off right there. That's okay, that'll scrape free. That is very nice. It's got a small amount of pinholes in it. They're easily filled. This edge came out very nice. Very happy. That's a good part. That is. It's about a B+ finish. Need a little work to get it to that, shiny carbon. We're not doing that. We're painting parts here. Anyway, the fiber orientation is right on, and figure out what it weighs. All right, success. 3 pounds, 12 ounces, untrimmed. That's going to come in at probably 3 pounds, 6 ounces. All right, we're looking at this fit. Looks like it is 100% corrected. That is within a lick of glue, and we've got a nice, huge bonding surface. So that looks good. The other one is this one. Once this corner gets trimmed in a little bit, that'll come in much nicer. And this part of the fit is this. I'm feeling it on both sides, and that is what we're looking for. And it is now precise on both sides. That's what we're looking for.